All right, hey students, Mr. H here, obviously. At this point, you should more than likely have all of the example sets and notes ready for you to write on and get rocking, but if you do not, right, in the next little bit, go ahead and make sure you have all your materials because this video is going to serve as the first set of examples and concepts in Chapter 9. Now, as I've been talking about for the last couple months, we are in the geometry unit. So Chapter 9 wraps up the geometry unit by diving us into surface area, very similar to what we did with circles, semicircles, flat shapes, triangles, things like that in the last chapter, but instead of individual small shapes, we're going to go ahead and bring it all together into a 3D object like prisms, pyramids, cylinders, and find the surface area of those. So we're going to continue with our formula-based work. So at this point, I'm going to go ahead and switch screens, and you should have something that looks very similar to this. And on here, you will have the key ideas that you're going to follow along with a couple core examples. At any point during the video, if you need to go ahead and pause or slow down, just ask your teacher to go ahead and do so. All right, so without much further ado, let's go ahead and get this rocking. So the key ideas in this case are going to be a lot more formulas. Some of these formulas are going to be a little bit extended, but as usual, formula work means that you're going to have to memorize it a bit and then use it in context here. So the shape that we're going to discuss heavily in 9.1 is what you see me highlighting at the bottom. It is called a prism. A prism in the most basic form kind of looks like a box, okay? So a prism, though, has a couple very specific features that I will outline and sketch on here when we go through the key ideas. Prism is a 3D shape with congruent faces, okay, or bases. I'm actually going to call them bases, but you can think of a face as all of the sides, top, bottom, left, right, front, and back, connected by the flat sides or lateral faces. So the language of this section is a little bit different than you've seen before, but most of you will recognize that the bases are kind of considered the top or bottom. Now, that's not exactly 100% true every time because you can flip a prism on its side, things like that, but that's one of the easier ways to understand it. The lateral faces are what connects everything. So I'm going to zoom in on this. So this is a prism, and it is a rectangular prism, and this is what's called a net. You have worked with nets in the past. Basically, think of a net as a flattened out prism. We take a 3D object and flatten it out. If I was looking at something like this, the top and bottom would be considered the bases. I'm just going to label it B. And then the sides that wrap up in between the bases, those are called the lateral faces. Let's just label them LF. This is going to give you a good visual when we flatten it out to see how we can take a 3D object and flatten it out and make it a 2D shape. And this is how we get surface area. Surface area is the space on the outside. We did area of circles, triangles, and rectangles in the last chapter, but they were isolated, just a single piece. So think of a prism as a really organized composite with multiple shapes. The rectangular prism is our most basic one because it has a nice formula to it, and that's what we're going to study first. Then we're going to move into a triangular prism, which is a little more robust. All right, so let's get into the actual formulas. You need to know three specific formulas. The first one is the general surface area of a prism formula. General means that we can switch the shapes on you. A rectangular prism has a rectangle for the top and bottom, or the bases. A triangular prism, same thing, it has a triangle for the top and bottom, or the bases. But we could have multiple other types of bases. You can have a trapezoidal base. You can have a circular base. That actually becomes a cylinder later. So the general formula for surface area of a prism is that it's going to be the area of the bases, okay? I'm going to call that big B, okay, plus the area of the lateral faces. Now look at that notation I'm using. Okay, so big B stands for the area of bases, and A with a little notation subscript LF means area of lateral faces. What that formula gives us is a generic way of tackling any prism, or we can find the area of every individual flat piece and add it all up. Okay? There could be multiple lateral faces, not could be, there always is. But we're going to get right into the rectangular prism formula, because the generic or general formula gives us an idea of how it comes about, but the formula we will definitely use more consistently is the rectangular prism formula. So that formula is very smooth. Just looks a little weird right away. It's the surface area is equal twice LW plus twice LH plus twice WH. And the L, the W, and the H come from the dimensions of the prism. And in that diagram at the bottom, there they are, H, W, and L. Those are the specific dimensions that make up a 3D object, especially in this case with the prism. Think of it as the three pieces you need in order to get this rectangular prism formula's surface area. Okay. So we're going to go ahead and do or use that formula in a little bit. It takes formula work, just takes organization of the equation, so just be careful when we go over that. It's nothing different from what you've done in the past. All right, just a new formula. The surface area of a triangular prism is a little bit weirder. Okay, so I'm going to give it to you and we'll do it in context. The surface area, this example or formula I'm going to give you is not actually in the book. I've simplified it for you for the purposes of this unit. But when we go over it, if you look at the book example, it kind of just has you find each individual piece. But you can use this formula, which works out very nicely. So the surface area for a triangular prism formula is BH, that's the base and the height of the triangle, plus the height multiplied by the first side plus the second side plus the third side. Now this looks really crazy and really fancy, but in context in a moment when we use it, it smooths out the operation. I am going to put some call outs so you can understand what this is. This is the area of the triangle, the BH. That's the area of the triangles. And then okay, the height will be the height between the bases. S1, S2, S3, these are going to be the sides of the triangle. So this is a really nice formula. You are more than happy to use this all the time, though what some of you are going to find is that when it comes to triangular prisms, you can also get each individual piece and just add it up using that generic surface area of a prism formula where you find the area of the bases, area of lateral faces. All right, that was a lot of setup here. So if you need to pause right here, okay, ask the teacher to pause the video. I'm going to roll the tape for maybe a few seconds and then get into the first example here. All right, continuing on. Here we go. Let's look at our first example. This is a very nice prism. Okay, smooth, good numbers. It's practice with the formula. So what I would recommend always is to label, label, label. The width is at the bottom. That is going to be 3 inches. The length goes along the side there, 5 inches, and the height is 6 inches. That's the vertical part. If you label, this is make sure that we do not mess up what we put in. So finding the surface area of a prism, formula work means we're going to put the actual formula down, and yes, you are required to write this formula down every time. So you can see right there, it's 2LW, 2LH, 2WH, every combination of the 3 numbers. After that, you are going to properly substitute everything in. So these are all key steps that you're seeing. 2 times 5 times 3, and then keep on going from there. The tricky part about this formula is that it's so extended. It is a lot of numbers right there. There is nothing crazy about this formula. You just got to keep track of your workflow and make sure that you don't lose track of some of these numbers. After that, we are going to simplify. So at this point, we can simplify each individual piece. And yes, I do want you to do each individual piece and write it down so we don't lose track of our work. So you can see what I've got highlighted there, each individual piece. It's more mental math. 2 times 5 times 3 is 30, plus 2 times 5 times 6 is going to be 10 times 6, which is 60. And then the last one, 2 times 3 times 6, is 6 times 6, which is 36. At this point, you can just pop that into the calculator, though that is not too wild of numbers. 126 inches squared. We are still talking about area here, so it will be inches squared. There we go. That is a nice, very smooth formula, works very well. So at this point, pause this video if needed, and we will move on to a little wilder prism. That would be the triangular one. Okay. If there are any general questions, feel free to ask the sub, or pause and wait for the next part of this video. All right, students, your screen should have jumped to example 2 here. Here we go, surface area of a lovely looking triangular prism. I'm gonna state, if you understand how to break down the net, it is basically finding each individual piece. So you got the 2 triangle pieces and the 3 rectangular lateral faces. Works out very nicely, but if we use the formula, we just have to be careful in understanding what every piece means. So I'm going to use the formula. I'm going to write it down. SA equals BH plus H, and S1 plus S2 plus S3. Now we got to be really careful. Notice there's 2 H's here. They're not the same H's. So in order to use this formula properly, we got to be careful not to confuse the different parts. The first part, BH, is only for the triangle. So I'm going to look at the triangle and think, okay, what is the base and the height? And as we talked about last chapter, the base and the height is always connected by a 90-degree angle. And notice on the net, I've gone ahead and highlighted it. Let me switch it to blue so you can see that a little better. There we go. So the base and the height of the triangle is going to be 3 times 4. So I'm going to put 3 times 4 plus, now pause right here because the rest comes from the 3D shape. I'm going to say S1, S2, and S3 are going to be the individual sides of the triangle. Okay, so on the bottom, notice there's a 5 meters at the top and 3 and 4 at the bottom. So I'm going to just write it in at the top so you can see what I'm talking about. S1, S2, and S3 are those sides. So I'm going to just label it S1, S2, S3. So even though in the original part of this formula at the very beginning, BH, okay, we kind of repurpose it or relabel it. So the confusing part of this formula is knowing what pieces go in here. So those are all S1, S2, and S3. Those are pieces of the triangle, sides of the triangle. So just think that's what S means. It's the sides of the triangle. The height is going to be the height that connects the top and the bottom, or the bases. So in this case, the 6 meters is the height. Not to be confused with the other height from the base times height triangle. So I'm going to put 6 here, and then I'm going to put 3. Well, I labeled S1 4, S2 3, and S3 5. Now I have a complete formula. So I'm going to say this again. The formula works really well, but the H is the most confusing part. The H for the original part, BH, is only for the triangle, base times height. And then the height on the second one is for the height of the prism. But it's really nice after this because with all formula work, it now becomes standard calculation. So 3 times 4 is 12 plus 6, and then 4 plus 3 plus 5, that is 12 again. Really, after this, calculator math, you can punch that out. But I do want to see the proper substitution and all of the general workflow to make sure we don't lose track of our work. So 84 plus 6 times 12, 12 plus 6 times 12 is 84 meters squared. At this point, that concludes this problem. We got the actual surface area of the prism. So the key thing, again, and I've said this probably about 3-4 times now, is that the heights can be confusing on this. We got to be careful of knowing what height it is for the triangle and then the height of the prism. But formula work is super organized, works really well because it allows us to just substitute in the pieces that we need. All right, at this point, this example is complete. If we need to pause this video, ask the sub to do so, and in a moment, I'm going to transfer you over to the OIO. All right, students, you should see that the screen popped and switched over to the OIO. At this point, I would like everyone to do the OIO. As usual, work with your shoulder buddy and the people around you to make sure you're on the right track. Look back at the examples and follow the example setups. That means all of the key steps: formula, substitution, then calculations. I'm going to let this video roll in silence for about 5 seconds. So at this point, tell the sub teacher to go ahead and pause this video. And when everyone in class is done, unpause it and the answer key will magically show up. Go ahead and get started. All right, students, the answer key should pop up on the screen. Go ahead and self-check and pause this video after I'm done talking. The big thing you're going to notice about 1 and 2 is just the workflow for the formula. You do want to label LW and H so you can keep track of those dimensions. For number 3 and 4 at the bottom, number 3 was pretty smooth in that the pieces came in right, with the base, the height, and the sides for the triangle are pretty easy to find. Number 4 was a little trickier because if you notice, it is a triangular prism, but it was flipped on its side. The bases of this shape are the triangles, and the lateral faces are rectangles. So even though it's flipped on the side, you have to be careful of what you put in for the BH triangular part. So 3 and 4 were once again the actual BH for the first part, but the height for the second part was 4, even though it was flat on the bottom. So I'm labeling it right now so you can see me write it in. So the height of that second, number 4, triangular prism is 4 at the bottom. It connects the two bases. All right, so pause this video at this point. I'm going to let it roll for a couple seconds before we transition. All right, students, so at this point, that concludes the lesson video for all the examples. Make sure you have everything organized, and you will transition into work mode, which your teacher will go ahead and explain to you, okay? So to recap, keep up on the formulas. You will be allowed a formula card for the Chapter 9 test, so and you will have it as a reference, but as you're using them in context with the different problems, you should start memorizing them, being able to know how to apply them, okay? All right, that works for this video. Thank you for watching. Enjoy the rest of your day.